So, hello guys, it's Kumar K, your favorite DSA teacher. When it comes to solving hard OA problems, hard CB problems, or whenever you want to improve your thinking skills, higher level thinking skills for hard unseen DSA problems, you always come to this channel, right? So, thanks for coming today as well. So, guys, today is a very pleasant day because you all know that we are going to solve Fang OA problem, right? Yes, right. Coming to my introduction, previously, I worked at Amazon and Media.net as a software engineer. I cracked those offers off campus. And coming to my love for DSA, I have achieved All India Rank 12 in Google Code Gem 2021, which is one of the toughest international algorithmic DSA competitions. Also, recently I have achieved All India Rank 4 in Facebook Meta Hacker Cup. So happy Diwali, guys! And we also have a special Diwali offer for all of you. You can check in the description below. The people who want the best training in the country for from scratch till advanced level DSA, OA, CP, system design, people who want one-to-one mentoring, referral of top 500 companies, and all those extra features, we have a brilliant program for you, and you can check it out in the description because the offer is running for this Diwali. So now let's start what we are going to do now. We are going to discuss this very difficult problem which was asked in Amazon online assessment. Guys, this problem was asked for intern role also and for SD role also. So this problem is very very important. Why? Because it was asked for SD role also and intern role also. Okay. So let's start reading the problem and let's try to make it very easy for ourselves. Okay, we need to make it very very easy for ourselves. So the name of the problem is. So, this problem looks very big and confusing at the first look, right? Don't worry, Kumar K is here for you to make it look easy to you, okay? So, guys, the question is pretty simple. They are saying that we are giving you two arrays, okay? Array A, array B. You have to convert array A to array B. That's all that they are asking to you. That you have to convert array A to array B. That's it. That's it. That's it. Okay. You have to convert the array A to array B if possible. Try to make maximum indices of array A equal to array B. Okay. So the goal of the question should be clear to you. Guys, see these level of questions we need to solve in our online assessment. Okay. That's why I tell you that don't just do standard DSA problems and standard DSA sheets again and again. That's not going to help you. You need to develop higher level, higher order level thinking skills. So please put your full attention and focus on this video. Okay, so guys, if I try to talk about the understanding, they are saying that you have given two arrays A and B, make A equal to B using some operations, or we can say try to make maximum indices of array A equal to B. That's what they're asking. I am giving you two arrays. Try to make maximum indices of array A equal to array B. You can check that in the question also. They have written the same thing, right? We can check in the output also. Yeah. Okay, okay. We can see that the length of the array can be as large as 10 to 5, and the input elements of both the arrays A and B can be as large as 10 to 4. So I want to make maximum elements of array A equal to array B. Then my job will be done. Whenever someone tells you maximum, minimum, always things in terms of greedy algorithm, binary search, dynamic programming, something like that. So given two array A and B, make A equal to B using some operations. You don't have to make them completely same. Just make sure the maximum indices of A and B should match. What kind of operation can we do? Okay, guys, we can in one operation we can select any pair from A and I comma J, and we can increase a number by 1 and decrease another number by 1. But you have to make sure that the number which we are decreasing by 1 is already a positive number, so it does not become negative. Can you see how complicated they have tried to make the question for you? So they are saying that how will you make this array A and array B maximum index equal? So guys, in the good case, everyone should be equal. So this is matching this. Good, 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 good. This is matching this. Good, 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 good. These guys are not matching. So I will do the operation of I comma j. I comma j means ai will increase by plus 1 and aj will decrease by minus 1. So guys, what will happen if I increase ai by 1, it will become 9, and this thing if I decrease by 1, it will also become 9. So guys, 9 9 matching 9 9. Good, good, good. So output is 5. All 5 indices we have managed to make sure that they are matching each other. Okay, so you can see how nicely we tried to do it, right? Yeah, we did it. So let's keep it always pretty simple. Okay, so given two arrays, please tell us that what can you do and how can you do to make sure maximum indices of array A is matching array B. Let's take some input example given by, like, of the type for which was given by Amazon only. So 241 1 2 3. Okay, 241 1 2 3. This is array A, array B. Operations you can do only on array A. So guys, how can you make these guys matching these guys? So guys, first what I can do now, I can select this as J, this as I. So this number, one, one will reduce here, right? So 1 and 1 will increase here, right? 5, 1. So what has happened? See, this index has started matching this index value. Good, good, good. Now here what can I do? Okay, I want to make it equal to 2. Let's try a random algorithm. Let's try to make this 5 2. So what you have to do? This should be your j, right? This should be your j. And this should be your I. So what will happen if I do that? 1, this becomes 4. 1 decreased and 1 increased there. So 4 2. Then I will do this operation again. I will keep on decreasing this 5 until it becomes 2. So if I decrease again, it is 3 3. See, this is j, this is I. This guy always decreasing by 1 and this guy always increasing by 1. Now if I do it again, it will become 1, decrease by 1, increase by 1, 1 2 4. So guys, my final arrays are this first array 1 2 4. This remains as it is. So guys, this is the best solution because this index is matching this index. This index is matching this index. This is not matching, but we were able to make two of the indices match. Earlier there was zero matching. The worst answer can always be 0 only, and the best answer can always be n. So lovely people, I really hope that these basic observations were clear to you, right? Right. So you can also solve these problems, don't worry. So guys, what is the first observation coming? Maximum answer can be n and worst answer can be 0. 0 means you are not able to make any index of array A and B match. N means you were successful. All started. So this much we have understood that the maximum answer can be n and the worst can be 0. But guys, now how do we approach? How do we solve this problem? See, one normal intuition which is coming to mind is that we can always solve this question if the array is of size 2. Always try for smaller sizes before. So if the array is of size 2, let's say this is 2 5, okay, and let's say this is 1 comma, let's say this is 2 5, right? 2 5, which is the sum is 7, right? And this is like this is array A, this is array B. So guys, one thing comes to the mind, that no matter how many operations you do on array A, the sum of array A always remains the same. Sum of array A is always constant. Why? Because you randomly select any two indices on array A, you do plus one to this guy, but at the same time you do minus one to this guy. So plus one minus one total sum remains zero. Okay. The sum of array always remains constant after all the operations. So whenever I see a number which is not matching now, what can I do? I can just remove the extra number. See, here it is 2, it is 1. So I only want a 1 here, right? So I will break it in two parts. 1 here, 1 here. The extra part I will send it to the next number. So it will look like 1, 6. And see, now it's matching. So this is the general intuition coming up. Why did I show you that like this we can solve for arrays of length 2? Because these are the general intuitions which will come in your mind when you're trying to solve in the exam. You can easily see that whenever the array is of size 2, we are able to do something. But how will you solve for greater than 2 size? We need a proper visualization for it. We need a proper visualization for it. Okay. So how will we visualize? The solution is that in these problems, always sort the array. Let's sort the array B. Guys, let's sort the array B. Okay. So this is the most important thing, that we are going to sort the array B and keep indices of array A in the same order. This helps us with the visualization and then gives birth to a brilliant greedy algorithm. So just sort the array B and then see what happens. So guys, let's take some examples, right? So let's say array B is something like this, okay? Okay, and array A is something like this. Now what will I do? I will sort the array B, but I will make sure that the numbers at array A remain at the same index only. So when I do the sorting, now I need to do the sorting smartly. I will put these guys in a pair like this. Vector of pair or array of pair, and I will sort according to the first index. These will all be the B elements and these will all be the A elements. Okay. So guys, if I do the sorting, how will everything look like? Things will look like this. Array B will look like array B will look like 1, 5, 8, 8. Okay, sir. Array A will look like 1 was attached to 2, na? So 2 will come here. 5 was attached to 8. 8 comes here. 8 was attached to 10. 8 was attached to 10. Now guys, sorting does really a brilliant job in this case. Okay, so let's see what magic is sorting doing. What magic is sorting doing? So guys, what has happened now? See, you can see that you want to make all the elements of A equal to B, right? So how can you make 2 equal to 1? 2 is bigger than 1, right? 2 is bigger than 1. So I will break 2 in 1 parts, which is 1 plus 1. This number I will keep here only. Extra part I will send on the right hand side. That's it, guys, and the problem is solved. So what will I do? And guys, yes, one more thing someone might ask, that sir, is sorting not changing our question? See, when you sort the array B, what happens? The structure of B array changes and the structure of A array changes, right? Right? But their bonds remain the same. I'm still trying to make the same indices equal. Okay. See, When I sorted array B, I made sure कि जहां B में 5 लिखा था उसी के ऊपर अभी भी 8 लिखा हुआ है. तो I changed the order, but the structure, vertical line structure remain the same. मुझे इन्हीं indexes को equal करना था, वो मैंने same रहने दिया है. So that's not the problem. Okay. So what has happened is that now in array, whatever is extra, na, you will send it on the right hand side. That's it, and the problem solved. So here, what it is, guys, 2, na? 2 is extra, 1. So what is the difference between 2 and 1? 1. So I will write a 1 here. 1 is extra. Send it on the right hand side. So 8 plus 1, 9. That's it, guys. Now what? 9 and 5. Guys, 9 is a big number. So divide 9 into 4 plus 5. 5 plus 4. Right? So 5 I will keep here and 4 I will send ahead. So basically 4 time I will do the decrease operation here and 4 time the plus 4 will go here, right? So the common sense says that whatever is the extra, na, send it on the right hand side. So guys, 4 is extra, so send it on the right hand side. How will it look like now? 1, 5, 4 sent on the right hand side, 14, 10. An array A looks like yeah, array B looks like before only. We make no changes to array B. See guys, this has become equal, this has become equal, so you can forget these guys. Just assume that only this array is left, because you cannot make any change in the past because those guys have already become equal. This is the, guys, such a brilliant greedy algorithm is this, that if you solve for index 0 and then when you try for to solve for index 1, only check the elements from index 1 to index n, don't check the past, because a of 0 has become equal to b of 0, so you don't need to change them again. So the algorithm becomes easier. Okay. So now 14, 10, 8, 8. How will you make them equal? So this has become 1, 5, 1, 5. You don't need to check them. They have become equal. Here it is 14, 10, 8, 8. Now what will you do? How much extra it is? 6. So it is 8 plus 6, right? So 8 here plus 6. So 6 I will send on the right hand side. 16 comma 8. Okay, in the end I cannot do anything, but at least I made 3 indices match, guys. So this is a brilliant achievement that we were able to make a 3 indices match. It's not a small thing. When can we make all the indices match? If sum of array A is equal to sum of array B, then the answer will always be n only. Okay. In this particular case, answer will always be n operations. So guys, I hope you understood all that I said till now. Okay. All that I said till now. Okay. So now, let's go further. So what is the biggest observation? That if sum of array A is equal to sum of array B, then the answer is n. Else we know what to do. You have done the sorting. If A of 0 is greater than B of 0, guys, what will you do? Whatever is the extra part. What is the extra part? Extra part is A0 minus B0. Now put it on A1. That's it. And if they're already equal, do nothing. That's it. Now, guys, one last question you should ask. Why is this greedy algorithm working so brilliantly? Why? We need to go in the very in-depth, the essence of the problem to understand what is happening and how the things are happening. Only then we can say that, yeah, we have become brilliant. So what is happening here? Let me show you by a very small example that what is happening here. Okay. So this is your array A, right? This is your array B, right? So what's happening? That if this guy is matching this guy, the array B has been sorted and array A has also changed the positions depending on the bonds. If this is already equal, if A of 0 is already equal to B of 0, do nothing, go ahead. Okay. If A0 equal to B0, do nothing. Now, if this is also index 1 and this, then try to make a1 equal to b1. But what if a0 is greater than b of 0? You only think. This is array A, this is array B. This is 10, this is 3. What will you do? You just want 3 here. 7 is extra, right? So you put that 7 on the next. So whatever number is here, you put plus 7 here. So 7 gets removed from here. So 3 becomes equal to 3 and plus 7 here. So you keep on shifting the extra part on the right hand side. But guys, someone can ask you, okay, these have become equal. Now you don't check the past. Now you only solve for this much part of the array. So always you have some remaining array which you want to solve for both of them. You are at index I, you are trying to make AI equal to BI. You never check the indices from 0 to I minus 1 because they all have been solved already. Got it, guys? Clear. So, whenever I'm trying to make AI equal to BI, if my AI is bigger than BI, what will I do? Very simple. Keep the part you require here and the extra part on the right hand side. But by guys, why are we putting the extra part on the right hand side? You cannot put the extra part on left hand side because the left hand elements have already become equal. Okay, guys, the left elements have already become equal. तो तुम अपना extra baggage पीछे नहीं डाल सकते, वो already equal हो चुके हैं. Okay, I hope you understand this much. Okay, so the what I mean to say is, let me explain you with a simple trick. Let's say this is array A. Let's say B is already sorted. Okay, like this: 1, 2, 3, something like this. And array is like this: 1, 5, 8, and something like this. So आपको क्या दिख रहा है? यहाँ पर आया सब इक्वल है, तो forget this part. Now you come here. This is extra, right? So you will say that, sir, I will write here a 2. 3 is extra, sir. 8 plus 3 I will do here. Now someone can ask you, why did you send plus 3 here? You can send the left also. Now you cannot send to left. If you send to left, the equal nature will go away. See, left में which elements we had, we are already equal. So if you add plus 3, this will not be equal anymore. That's why I am transferring all the baggage on the right hand side using greedily. I am transferring the baggage on the right hand side. And guys, why transferring the baggage on the right hand side is a good idea? Why is this good according to the greedy algorithm? Greedy always tells you to make a choice which is good for the current situation also and the future situation also. So if you transfer plus 3 on the right hand side, it's a good idea for current situation already. Why current situation? Current mein I am getting here 2 and plus 3 going ahead, so it is good for current. But why it is good for future also? You are sending numbers. Basically you are sending your soldiers on the right hand side. It's going to help because array B is sorted. In future there will be big numbers in array B, so you need some ammunition and strength here to tackle the big numbers of array B. That's why sending your help on the right hand side is a good option for future also. That's why, guys, I really love greedy algorithm. Whoever can master greedy algorithm, they will always master OA and CP. CP in particular. So this is a optimal greedy choice to send the extra baggage on right hand side, because array from index see, if AI is you have to do this for all index I. Okay, send the baggage on the right hand side of A, because all left hand all elements from 0 to I have already become equal to the elements from index 0 to I. Also, array B is sorted, means larger numbers are there from index I plus 1 to n minus 1. Hence, you transfer extra value on the right hand side because it can help in future. guys, but a last case we need to discuss, and then our problem has been solved. We can do it in O of 2n. Okay, so how? What if a of 0 is less than b of 0? Then you will just run a two pointer. I love this problem. So guys, so we have basically solved the problem. What we have to do? Sort both the arrays, right? Like sort only the B array, not both the arrays, only the B array, but make sure that the bonds of A and B remain the same. Okay, A will not get sorted, but B will get sorted. Now you start traveling from the start. Okay, you start traveling from the start. This is array. This is array B, which has been sorted along with the bonds of A. हाँ, maintaining the bonds with A. ऐसा नहीं कि A को वैसे ही रखा और बस B को सॉर्ट कर लिया, नहीं. B के जो A के साथ बॉन्ड्स थे वो भी सॉर्ट हो जाने चाहिए. So array B is sorted. Array A, the bonds have been maintained. Okay, these are the bonds. We have to make these indices equal, na? If A0 equal to B0, you guys know what to do, so I'm skipping that part. Equal है तो आगे जाओ. If A0 greater than B0, you will greedily, what will you do? समझो ये बड़ा है तो क्या करोगे, इसको दो पार्ट में डिवाइड करोगे. One will be part will be B0, another part will be A0 minus B0. So A0 is basically B0 first part plus A0 is bigger na, A0 minus B0. So this extra part you will add it to the second number. Like this you will keep on doing until your index is less than equal to n minus 2. You cannot do anything on index n minus 1 because here there is no option. You cannot use anything from 0 to n minus 2, no, not there is any further index. So you know this also. But guys, what to do if A0 is less than B of 0? Now it gets interesting, right? Yes, sir. So let's say this is the array. Guys, this is 5. What is the requirement? You need more plus 5 here. So you need 5 numbers from somewhere. So go and search on the right hand side now. Okay, 2 I got, great. But still I want 5. 2 plus 3, 5. Yeah, these two numbers, I will extract them and I will put them here. That's it. Just extract them all and put them here. So you just keep a simple J pointer, guys. See. क्या करोगे आप? यहाँ पर हो, आपको दिख रहा है मैच नहीं हो रहा है, तो j इक्वल टू इनिशियलाइज टू I plus 1 and then check, is 2 enough? No, it is not enough because I want the sum of numbers should be greater than equal to 5, then only I can extract na. Again move your j add. Is 2 plus 3 enough? Yes. So whatever numbers you got here na, update them to 0 because now they have been exhausted, and add that to this value. So whenever your array is going on, you are at index I, right? So you are at index I, guys, okay? Okay. Array A, array B. And you came to know that AI has become less than BI. So what extra numbers you need? You need BI minus AI, okay? So you will implement your J like this because previous elements you cannot change them. They have all become equal already. And this J will start going and start collecting the elements until their sum becomes equal to need. As soon as they become equal to need, the J will stop here, okay? And as you go on, so make them all 0 because you have removed all those elements, and you put them all the guys here. So this will become equal to this. Now you continue the same algorithm again. Now try for AI plus 1, etc, etc. But make sure your J pointer remains like this only. Okay. Now if J has come till here, J will remain like this only. Okay. Now again when you come try to get some numbers in the future, you will start from this J only because all the numbers here have been exhausted. So basically इस चीज को efficient बनाने के लिए हर बार आपको j इक्वल टू आई प्लस वन इनिशियलाइज करके नहीं जाना है, नहीं तो एन स्क्वायर एल्गोरिथम हो जाएगा. आपको क्या करना है, when it happens for the first time, let's say you are traveling from 0 to n minus 1, this is the first time When AI has become greater less than greater than bi is very simple. You know what to do. Send the extra help on the start. Now you understand why I was sending extra help at the start. But if AI is less than bi, I need something. How much I need? I need bi minus ai. So when it happens for the first time, I declare my j as I plus 1 and I start traveling here to get the element sum greater than equal to need. As soon as I get them, I put all them 0 and I transfer them here. But now the j will remain at this position only. क्योंकि अगर फ्यूचर में कोई और बंदे को कुछ चाहिए तो वो डायरेक्ट यहां से मांगना चालू करेगा, पीछे के तो सब जीरो हो गए ना. So I will also move from 0 to n minus 1 and j will also simultaneously move from 0 to n minus 1. And guys, in O of 2n, you solve this. So guys, this problem is so brilliant. See, first of all, we came to know that we should sort the B array, maintaining the bonds with array. So the indices remain at the same point. Now we forgot the whole problem, only focusing on A0 and B0. A0 and B0, nothing is there on the left hand side. All you can do is focus on the right hand side. So to make them equal, if they're equal, go ahead, no problem. But if A0 is, let's say, bigger than B0, send the extra on the right hand side. If it is less, go j equal to I plus 1 and try to get something to make them equal. When A0 become equal to B0, you go and check for A1 and B1. Now you forget the left hand part. Now the array is only from 1 to n minus 1. So again the same greedy algorithm applies. Such a brilliancy it is. I hope you can feel it with me. Also, guys, I will be regularly uploading the high quality OA videos, OA video solutions. So you can write in the comments of this video that which OA video you want next. Salesforce OA, Dish OA, many companies OAs are there. Also, guys, we have this, live training group where we give some free live training each weekend. You join there, there we will discuss DSA, OACP, okay? So let's do all of that. Love you all. And Ram Ram, Ram Ram, Ram Ram, Ram Ram.